Differential equations, we're in section 2.4, day 2, and we just worked out on the first video how to find an integrating factor to help make this differential equation exact. We found the integrating factor was y to the third. So what you will do is you'll multiply y to the third everywhere. What you do to one side, you're always going to do to the other side. And even right here on the right-hand side, we'll do that just as well. But we'll have x, y to the fourth dx. This will become 2x squared y to the third plus 3y to the fifth minus 20y to the third dy equals 0. And guys, bold claim, we have a brand new m and a brand new n. We're hoping that what we had just done actually has made this new equation exact. Let's see if it is. I'm going to take my derivative of m with respect to y. Maybe put this m a little bit higher up here. And you can see that you'd have a 4x y to the third. Let's take our n with respect to x. And you'll get a 4x y to the third. And the derivative of these other two terms are 0. Sure enough, what we just did worked. It has shown that we have an exact differential equation. And what that really means is the derivative of our function f with respect to x is right here, x y to the fourth. So I'm going to take a integral on both sides with respect to x, and we'll have f. And this is going to be x squared y to the fourth all over a 2. Bump that power of x 1 higher. But of course, the constant that we're going to have, realizing that y is thought to be a constant, we could say, look, we could have a function of y. But if we take our derivative with respect to y right now, what we should be getting is n. So we're going to do that right now. As we take our derivative, bring 4 down, and we'll have y to the third all over a 2 plus g prime of y. And we're saying, look, this should equal 2x squared y cubed plus 3y to the fifth minus 20y to the third. And this is just going to become a 2x squared y to the third plus g prime of y. And you can see nicely we're going to get a little bit of canceling to occur. And I'm going to change colors real quickly and get a 2x squared y cubed. You can subtract that from both sides. And now I'm just going to take an antiderivative with respect to y. This gets bumped up to a 6, and when I divide by 6, 3 over 6 is 1/2. And you can always double check if you've done this right by quickly taking a derivative. This gets bumped up to a 4, y to the fourth, but when you divide by 4, 20 divided by 4 is a 5. Double check that you're right by taking a quick derivative, and then we'll have a constant plus c. So one other thing I really want to point out to you, and this is so critical, is that really at this earlier stage, we found that f, and I'm going to maybe raise this back up here, f was equal to x squared y to the fourth all over 2 plus, well, now I know what this g of y is. We just found that at the bottom. We can bring it back up. We're going to have 1/2 y to the 6 minus 5 y to the fourth plus c. But of course, the general motivation for having this is to find an equation f is equal to c. So the final answer that I'm going to write down here is to take this function that we just saw and just say it's equal to a c right here. So hopefully this is getting more comfortable for you. That concludes 2.4 day 2.